Now the topic is AC circuit analysis. Means a network with AC sources we are going to analyze. Analysis is nothing but see to find in any branch current, voltage and power by using all the techniques like series, parallel, star delta, mesh, nodal analysis and Hull theorems. Now here the basic definition for AC circuit means AC signal. So now onwards AC source, AC voltage source or current source. I can use the word as signal. Means AC signal means it varies with respect to time. Means alternating quantities varies magnitude with respect to time to time. Here in AC signal, AC voltage source, there DC signal we studied there, current always flows from positive to negative in only one direction. Here AC signal current will flows in the two directions. In two directions. So before going to studying about AC signals, let us discuss some basic definitions to understand AC circuits, alternating quantity. We know periodic waveform. The periodic waveform is nothing but what? The signal will varies with respect to time, period to period. The same signal will come. Suppose if any one signal is existing at certain period, after some period, same will repeat. That is called periodic waveform. If aperiodic waveform means each time the same signal won't repeat. So periodic waveform we can also call it as symmetric waveform. Symmetric means positive half cycle is mirror image to negative half cycle. Examples for symmetric waveforms are sinusoidal signal, square wave, sawtooth, triangular, etc. etc. Now here in AC signal, what I said, current will flows in the two directions, means on off signals. These are to understand this. Suppose you take one practical example. Suppose older days in our homes normally, if you are operating any electrical appliances, a switch if you are operating on off if you are doing, some old people make it say the load equipment may damages. It won't damage. Actually you are getting the signal is on off signals. That on off is varying very fastly. That's why you are able to seeing the object. Suppose if that on off is 2 times per second, means on off light you take on off per second, one time on off you're doing, the time you can't see the object properly, your eyes will get disturbances. If the on off is very fast, means in 1 second 50 times the on off signals are changing, then you can't see that disturbances. That's why for fine tuning means clear intensity of eye, the Indian standard frequency we set it as 50 Hz. First, before going to knowing the frequency, we have to know what is cycle. So waveform is nothing but a graph which is the waveform between the two quantities. If you draw with respect to time or voltage, time versus current, by the instantaneous value, if you draw the graph against a time for any quantity, that is called waveform. Now what is cycle? One complete set of positive and negative half cycle of alternating quantity is called as a cycle. If anything is started at one point, at same thing is starting after what time? After some same thing if it is started, that is called the cycle. And the time taken to complete one cycle is called time period. See the definition: time taken to complete one cycle. And come to definition of frequency: the number of cycles per second, number of cycles taken per second. See the differences between cycle and time period. Time period is nothing but time taken to complete one cycle, time per cycle. Here frequency, number of cycles taken per time, particular time. Means you can say with this f is inversely proportional to time period. The differences, just opposite differences. F is inversely proportional to time period. I said Indian standard frequency is 50 Hz. Why? Because all loads are designed to work for 50 Hz. That's why standard frequency Indian government is generating 50 Hz. How you can take my 50 Hz is in the generating station. So conductor has to rotate with a certain speed. Frequency is nothing but speed related term. If in the conductor, say I'm assuming conductor is rotating part, magnetic field is stationary. If conductor one part is positive half north pole, positive half cycle will generate. The same conductor part is north south pole, negative half cycle will exist. So means if conductor is completed one revolution means one set of cycle it is getting positive negative. So like that per second it has to complete 50 revolutions, then you can get 50 Hz frequency. Means giving mechanical energy should be constant. If mechanical energy changes, frequency may changes. So by using standard sensors nowadays in generating station, conductor rotation is maintaining constant. With that you are going to you will get constant frequency. Next, amplitude. The maximum positive or negative value of any alternating quantity is called amplitude. Magnitude is also called peak value. The waveform, if you take, now we are going to studying about only sinusoidal signal. Why? Because in the generating stations we are going to preparing voltage source also in the shape of sinusoidal signal. Remember, we are going to studying about only voltage source practically. Theoretically there is no current source. Theoretically only we are going to studying about current sources, but practical current sources doesn't exist. Why? Because all our loads are what I said, resistive loads and inductive loads. For resistive load and inductive load, current sources won't support. Voltage sources only will support for the resistive and inductive loads. If our loads are capacitive loads, voltage source doesn't support. Again we have to use their current source. But all our loads are resistive and inductive loads, as we discussed. Resistive loads are nothing but all light and heaters. Inductive loads are nothing but all rotating motors or fans, any, etc. That's why we are going to studying about only voltage source. That source signal shape is sinusoidal shape. Why? Because sinusoidal, to apply Fourier series analysis is easy. Analyzation is easy on sinusoidal. Why? Because inverse Fourier sine also sine wave we can get. Suppose a differentiation d by dx of sine, d by dx of sine cos, d by dx of cos sine, means the signal shape is you are getting the same. The phase difference between one, if there is two sources, between one source to another source, what that displacement representation is called phase difference. Phase difference means those, and if you consider two signals, comparison, if both are not reaching maximum values at the same time or not reaching zero at the same time, then we can say the phase difference is existing between those two signals. Phase difference is denoted by letter pi. Suppose if any one signal is reaching maximum value advancedly compared to other signal, then we can say that signal is leading. If any signal is reaching its maximum value later the other signal, then we can say that signal is lagging with each other. Lagging, leading, discuss in depthly while discussing about AC circuits through RLC parameters. Remember, leading always represented with the positive signal, lagging we represent with the negative signal. Because vectors always rotates in anti-clockwise direction. If anti-clockwise taken, then we can consider positive polarities. Negative clockwise direction we represent negative polarities. This, remember, keep in mind this only. We'll discuss later about while discussing about J operator. Now see in this diagram here, I assumed VA starting at 0, VA as Vm sin omega t. Then VB is equal to VB reaching maximum value before to A or after A? Before to A it is reaching. That's why you represent VB as Vm sin omega t plus pi. Vm sin omega t plus pi. Means here we can say phase B leads phase A by an angle some pi, some phase difference pi. Angular velocity. You know the definition for velocity. Velocity is nothing but what? Distance by time. Here angular velocity. angular distance by time. So angular, how much distance it is traveling to take per cycle? 2 pi radians, 2 pi by t. So 1 by t is nothing but what? Frequency we study. So if you replace in place of 1 by t, you can get angular velocity is equal to 2 pi f, which is denoted by letter omega. So frequency 2 pi is constant. Frequency units are nothing but what? Cycles per second. So angular velocity units are cycles per seconds. Cycles per seconds. Instantaneous value. The instantaneous value of alternating quantity is its magnitude at any instant of time. At any instant of time. See, instantaneous value is always to be defined with the lowercase letters. Why? Because time varying quantities we are defining with the lowercase letters, and time invariant quantities we are going to defining with the uppercase letters. So instantaneous value, sine wave it is. So represent this as voltage. Suppose if you take a voltage source magnitude, instantaneous value of voltage is equal to Vm sine omega t. If you know V maximum value, we can calculate at any instant of time that instantaneous value of magnitude. Similarly, current source also. Next, peak value. The maximum amplitude of instantaneous value is defined as peak value. Next, peak to peak value, maximum positive to maximum negative. It's called peak to peak value. Next definition, alternating quantities. Any quantity, voltage or current, whose magnitude has alternating values with respect to time repetitively as time progress is said to be an alternating quantity. Examples, sine signal, square wave, sawtooth, triangle, etc. Now to discuss about periodic function definition. It is repeating at a certain time. Now, average value. Remember, average value. Average value. Suppose you take AC signal. AC signal. What I said. Positive half cycle is mirror image negative half cycle. Now onwards we are going to analyzing per cycle only. Why? Because if you analyze per cycle, next cycles existing also same. Next cycles existing also same. Why? Because in generating station, conductor magnetic field. So conductor rotations are same. For if you analyze for one cycle or if you analyze for n number of cycles, same. That's why we are going to analyzing now onwards for one cycle only. So for what is the average value? Average value for one cycle, positive half cycle is mirror image negative. We are calling it as AC signal. Means average value of AC signal what? 0. So average value doesn't exist for AC signal. Average value will exist for DC signal only. So this average value of time AC quantity represent based on charge transfer basis. Based on charge transfer. Now that's why to calculate average value for a half cycle of a time varying quantities, we are going to using the mathematical tool as Fourier series analysis. Fourier series analysis. According to Fourier series analysis, if we assumed f of t is a one function, then the average value of that function is equal to 1 by t integral 0 to t f of t into dt. By using this formula we will calculate. Here function, our function is what? F of t is nothing but what? Sine wave. So if it is a voltage source, Vm sin omega t, or if it is a current source, Im sin omega t. Capital T is nothing but here time period. So time period is nothing but what? Time taken to complete one cycle. Now for AC signal, if I want to calculate average value for one cycle, so what is the distance for one cycle? Time period 2 pi. So 1 by 2 pi integral 0 to, if you want to calculate per cycle distance, time is nothing but 2 pi. So 0 to 2 pi Vn sin omega t into d omega t. If we integrate it, we will get 0 value. So average value per cycle is 0. In some AC analysis applications, to define some terms, average value is not exist for sinusoidal signal. That's why we are going to defining average value per half cycle. For half cycle, what is time period? For half cycle only we are calculating means pi only. Means next is repeating negative, but if you consider this magnitude as positive, then 1 by pi 0 to pi. For half cycle only we are analyzing 0 to pi Vm sin omega t. If you integrate it, you can get a value as average value is equal to 2 Vm by pi. If you want in terms of voltages, 2 into V maximum by pi. Next, see, average value is not existing for AC signal for one cycle. That's why to define any one value per cycle, we are going to defining RMS value, root mean square value. This value will be defined based on heat transfer, because if current is flowing, current flowing through any conductor, heat will exist. Based on heat transfers, we define RMS value. See here, a very important point, RMS value is the same, root mean square, root mean value square of the variable. See here, basic definition. See, what is mean value? 1 by t integral 0 to t f of t dt. Root, square root I placed. Square of the variable, f of t square is specified. See, analytical method I wrote there already. See. Now we are going to assume here voltage source as a reference. So for average value of one cycle, VRMS is equal to 1 by 2 pi integral 0 to 2 pi Vm square into sin square omega t into d omega t. If you simplify this expression, you can get VRMS as V maximum by root 2. Similarly, IRMS is equal to I maximum by root 2. Keep in mind. If we want to define RMS value for half cycle also, consider half cycle 1 by pi integral 0 to pi, same square if you calculated, you can get again VRMS is equal to V maximum by root 2. Very important point to remember, RMS value for full cycle or half cycle both are same. Why? Because root mean square value we are calculating is same. Next few important terms, form factor. Definition for form factor is, it is a ratio of RMS value to the average value. RMS value to the average value. For one cycle, what is RMS value? V maximum by root 2. Average value how much? For one cycle or half cycle, V maximum by root 2. So average value is nothing but what? 2 Vm by pi. Vm by root 2 divided by 2 Vm by pi. So if you simplify, you can get as value 1.11. It's a standard value. Remember, form factor for sinusoidal signal is 1.11. Remember, it is for sinusoidal signal only. Square means if you examine also means that is different. Next, peak factor, also called crest factor, also called amplitude factor. It is defined as the ratio of maximum value to the RMS value. Maximum value to the RMS value. So maximum value is nothing but V maximum. RMS value for half cycle or full cycle is V maximum by root 2. With that you can get peak factor as 1.414. So to understand these definitions, I take one simple example formula problem. You practice once, just apply what is what you can understand. It means if any AC quantity, if given value is of 230 volts, means that value is always RMS value. If it is single phase, that is the phase value, RMS value. We'll say about three-phase system later. Next, analysis of AC circuits. AC circuit means source with different passive elements. Let us discuss about with a single individual element. After that, a combination of elements. That combination will exist again in series combination or parallel combination. First case, we'll see AC through pure resistor, means if AC signal is applied to the pure resistor, if AC signal is applied to the pure resistor, then what is power, what is current, and what is voltage across the resistor. See the network here, one AC voltage source I took here, a resistor is connected. If I asked how these two elements are connected, see there the existed nodes are two nodes, those are simple nodes, and the elements are also existing between the same nodes. Then we can say here these two are connected in series and also in parallel. That's why series properties will exist, parallel properties also will exist. In series property means current is same. See, current flowing, whatever is the flowing through voltage source, same current is flowing through the resistor. Similarly, whatever the voltage existing across the voltage source, the same voltage will exist across the resistor. Why? Because both are connected in series and also in parallel. So first we assume here instantaneous value of voltage V as Vm sin omega t. Vm sin omega t. Then if I ask current I is equal to what? Only resistor voltage source is there. I is equal to V by R. V maximum Vm sin omega t by R. So this Vm by this I can write as Vm by R into sin omega t. The V maximum by resistance, current maximum according to Ohm's law. So instantaneous value of current I is equal to Im sin omega t. Im sin, see the equation, see equation 1, Vm sin omega t. Current you are getting Im sin omega t, means those are flowing with same speed, and that too there is no phase difference. Then we can say these two are in phase with each other. These two are in phase with each other. Now if I draw phasor diagram, if I took voltage as a reference, voltage vector, and the current vector, where it will exist in the same phase, but current vector magnitude is always less than the voltage magnitude. Why? Because we are going to defining current I is equal to V by R. Resistance, remember, practically it is mostly more than 1. Impossible to get negative value of resistance, so positive values, that too more than 1. That's the current magnitude we are going to defining lesser than the voltage. So phase difference between these two is 0, means both are in phase with each other, in phase with each other. Then we can say power factor. Power factor is nothing but what we discussed, cosine of the phase angle between phase values of voltages and current. So phase angle is 0, so cos 0 is equal to 1. Now instantaneous value of power is equal to instantaneous value of voltage into instantaneous value of current, P into I. Now if you want to calculate average value per cycle, the average value, why power average we are going to calculating is power to discuss average power, or active power, or true power, or useful power we defined. Next, apparent power, useless power, complex power we discuss. Apparent power, useless power, imaginary power, wattless power we defined. Means average or in that word useful power. So whatever the power we utilized, for that we have to derive expression. That's why we are now onwards we are going to deriving expression for average power only. Real power, true power. So for applies what we are using, we are going to using Fourier series analysis, average value. So 1 by 2 pi integral 0 to 2 pi Vm sin omega t into Im sin omega t into dt. Now if you integrated and substituted values for average value, you will get as V maximum into I maximum. If you want it V maximum into I maximum by 2, this we can write as V average power is equal to Vrms by root 2 Irms by root 2. Why? Because RMS value is nothing but what? V maximum by root 2. So we are going to define in terms of RMS values expression per power as Vrms into Irms. Remember, across the resistor expression per power is Vrms into Irms. Next, AC through pure inductor. AC through pure inductor. See, one inductor I took, voltage source is connected. Here also elements are in series and also in parallel. So if I apply KVL, here is equal to supply voltage equal to voltage across inductor. Supply voltage nothing but what? Vm sin omega t, which is equal to voltage across inductor is equal to V is equal to L into di by dt. L into di by dt. So from this, if I want to derive current expressions, I have to integrate both sides with integral into dt. So d by dt, integral dt will get cancelled. You can get I as I is equal to 1 by L integral Vm sin omega t into dt. Vm sin omega t into dt. Why? Because integrating both sides with the integral dt. Now if we integrated that, you can get expression as V maximum by omega L, because sin omega t into dt there. So in by omega will come integration into integral sign is minus cos omega t into dt, and cos omega t into dt. This you can write as Vm by omega L into minus cos, we can write as sin omega t minus pi by 2. Sin omega t minus pi by 2. Nothing but correct expression. So here I maximum is nothing but what? V maximum by omega L. Here omega L we are going to defining with letter X suffix L, which is called inductive reactance. Units are ohms. Why ohms? Because see, 2 pi FL is there, 2 pi constant, frequency units are nothing but what? 1 by seconds, and inductor units are nothing but what? Basic units are actually inductance we are going to define with henries, but basic units are volt amperes per seconds. volt seconds per ampere, sorry, volt seconds per ampere, seconds cancel there, we can get volts per ampere. Volts per ampere is nothing but ohms. That's why inductive reactance will difference with the units ohms. Now we see above current expression and voltage expression there. Voltage expression Vm sin omega t, current I is equal to Im sin omega t minus pi by 2, negative represent with lagging later. So you can say here current lags voltage by an angle 90 degrees. 90 degrees means if I taken voltage as a reference, so current negative angle you have to take. That's why from voltage current you have to move in clockwise direction up to 90 degrees, negative 90. So current here going to representing in downward. Now instantaneous power is equal to V instantaneous into I instantaneous. V instantaneous Vm sin omega t. I is nothing but Im sin omega t minus pi by 2. If you integrated this, we have to calculate average value. So average value is nothing but same for one cycle. If you calculated one cycle, you can get expression as 0. Means power doesn't increase across the inductor. Means inductor doesn't takes any power. Whatever the power it was taken, again it will gives power to the network as per requirements. Next, AC through pure capacitor. See, both are connected in parallel. So supply voltage is Vm sin omega t. Voltage across inductor is 1 by C integral I dt. 1 by C integral I dt. So we need to define expression per current. That's why we have to differentiate both sides with the d by dt. If you differentiate it, you can get expression per current as I is equal to C into V maximum into cos omega t into dt. This we can write as I is equal to V maximum by 1 by omega c here. See, V maximum into omega c I am writing as V maximum by 1 by omega c into sin omega t plus 90 degrees. So for here I maximum is nothing but what? V maximum by 1 by omega c. 1 by omega c we are going to assuming as x suffix c, which is called capacitive reactance, and these units are also ohms. These units also ohms. See the expression 1 and 2 here. Voltage is started at 0, but current is getting plus 90. Means with this we can say I leads voltage by an angle 90 degrees. Leading means you have defined positive. I mean, that's why voltage, if I was taken reference positive 90, you can get in anti-clockwise direction. Anti-clockwise direction. If you want to assume current, then to define voltage, current is from current, how we are going to reach into voltage in clockwise. Means we can say here voltage lags current by an angle 90 degrees. Otherwise current leads voltage by an angle 90 degrees. So here power factor, cosine of the angle, what is the phase angle between those 90 degrees? So cos 90 is equal to 0. So power factor is equal to 0 here. If you define the expression per power also, we can get 0. We will get 0. This is about AC through single AC analysis through single passive elements. In next session, we'll think about combination.